Under 8.6, we want to learn how to find a mean or expected value of a discrete random variable. And the expected value of x is defined as ex, which is the same as sigma x, probability of x, which is also the same as sigma x, probability of x is equals to x. Please remember that anytime we have P, the probability of x is the same as the probability of x is equals to x. Remember, this is also very true. The second point is that if you have a statistical experiment, a practical approach results in a frequency distribution and a mean value, and a theoretical approach results in a probability distribution and an expected value. So in example 9, we're going to find expected value, which eventually is going to be the mean of x. And saying the number of television sets per household in a survey of 100 houses in a town gave the following frequency distribution. And of course, we have to have the number of sets, and this is going to be our x. And we are going to have the frequency, or rather the number of households, the frequency, which is obviously our f. There are some houses with 0 television set. There are 10 houses. With 1 set, there are 75 houses or families. With 2 television sets, these are 10 families. And with 3, 5 families. First of all, we need to find the mean. Find the mean of this set of data. If you want to find the mean, the general way we know how, we have to have the column of fx, which is going to be probably under this. The column of fx multiply, we have 0, 75 times 1, 75, 10 times 2, we have 20, and 5 times 3, we have 15. So the mean is going to be sigma fx over sigma f, which is 0 plus 75 plus 20, 95 plus 15, 110, all over 100 households. Because if you have sigma here, if you have a column of sigma here, you will have 100 and 110. So the mean is 1.1. So on average, each family is having 1.1 rather, television sets. Part B of the question, draw up the probability distribution table for the variable x, where x is the number of TV sets in a house picked at random in the town. Now, it is important to having said this is the mean, and I hope we are going to put it aside here. The mean is 1.1. We are going to use it and to compare something else. The probability distribution, let's just produce our table here. And we have the probability of x. If we are talking about what is the probability of picking a household with 0 television set. It is either we can only land on one of the 10 houses out of the 100 which is 0.1. In this case, the probability of finding a house which has one television set, we can only land on one of the 75 households out of a total of 100 houses, which is 0.75. And this is just 0.1, and this one is 0.05. I don't know whether this one adds to 1. Of course, it does. 0.75 plus 0.2, 0.95 plus 0.05 is actually 1. And that is how we can answer part B of the question, which was asking us to draw up the probability distribution table for the x. Part C, find the expected value of x. Find the expected value of x. And we have said that the expected value of x is the same as sigma x, the probability of x. And let us just use this one because that's what we have. If we have, we have to have another column. We have to have another column. We have to have another column of xpx. And we can see the probability of x is this one, and x is 0. So 0 times 0.1 is simply 0. The x here is 1 times 0.75, 0.75. 2 times 0.2, because this is the probability of x. When we have two television sets, this is 0.2. 3 times 0.05 is just 0.15. When you add all this to get the sigma aspect, 0.75 plus 0.2, that is 0.95 plus 0.15, 0.95 plus 0.15 is simply 1.1. And at that point, it is important that we can highlight this value, which is 1.1, and compare it with this value, which was the mean of the number of television sets in each and every household, and say the following. That we have seen that the sigma fx over sigma f is equals to sigma x px, which is 1.1. Both of them are equals to 1.1. And therefore, this is also equals to the expected value of x. It's the same thing. What can we conclude? The calculation for the mean and the ex are similar. For this reason, we can always say that expected value of x is sometimes called the mean. The expected value of x is sometimes called the mean of x. And either way, the mean of x is calculated this way, the expected value is calculated that way, and both of them give you one of the same thing. So, of course, now we can make a very clear conclusion that the expected value of x is the same as the mean of x. All right?